that when we get there. So for right now, it's k is equal to 1. Because that's just getting into a whole new. So, number 3. What about number 3? What's number 3, guys? Do number 3. What's number 3?
The number 3 is one of the examples.
Okay, still good, David.
Just practice. If you don't want to do number 3, do number 4.
Number 3 isn't that one of our actual like problems?
Do number 4.
Number 3 is one of our
It's do number 4.
homework problems.
Do number 4.
We can't see the
Oh,
interval.
sorry.
Thank you.
Number 4.
So we.
So the bigger number goes on
Number
top.
1 minus x.
The bigger number goes
Is
on
that
top.
number 4? Perfect.
Bigger number. Big.
Yeah.
Yes.
Because it's the right.
Did you guys get number 4?
Why do you guys hate me so much?
So what's number 4? The integral of 1 over 1 plus minus x from
From 3 to 2.
2 to 3.
2 to 3. Oh, yeah. Sorry.
Or, yeah, the lower bound to the upper bound.
Last time you said
Always
it
go-
from the higher to the lower.
I'm sorry, did I say higher to lower?
Yeah.
You said 5 to negative 7.
Yeah.
Okay, you always go the lower bound to the higher, upper bound. So you always say
it's 2 to
lower
3.
bound to the higher bound. So that was my fault, Okay, number, so those ones are pretty straightforward, guys. So let's look at evaluating these integrals.
That is not black at all.
It's like color just as black.
Wait, I'm gonna try.
Okay,
That's really marker napkin.
for the next problem,
Napkin.
So cool.
I feel like I'm dying.
I like it.
Have you ever gotten a bruise on your hand?
No.
That's so weird, huh?
It hurts. Yeah, bruise on. What? What?
Do you not?
Oh, sorry, my brain doesn't work.
I need
okay. So, guys, my thing went off,
It's
so
not
we're
as
gonna have to
sweet
do it
as
again.
most of the other
Sorry about
coffees,
that.
but it's like it's.
All right. So
You know?
when we are going, when we're doing, when we are evaluating the integrals.
Sugar.
Okay, guys, when we're evaluating the integrals, what we're doing is we're actually finding the area under the curve. That's what you're doing. So sometimes the areas under the curves are trapezoids. Sometimes they're straightforward and they're squares or rectangles. So, or they're semicircles. So in this case, it's a semicircle. So we can go ahead and use the area of the semicircle to evaluate this integral. So if the integral is given, then we can just find the area of this semicircle. And that's the actual answer for that. That's how you evaluated that area under the curve, okay?
Could it ever be a triangle as well?
Yeah, it sure can. Because how can it be a triangle? What's an example of a triangle?
I have a question. How do you
So, like, if you-
find
if-
a graph if it's a semicircle or a triangle?
Okay, so here's our graph. Let's say this is our graph. Is there a triangle right there? Oh, sorry. Here's our graph. So we have a triangle right here, right? And it's area equals base times height. And we see where that height is.
Right.
So we can just evaluate that right away. Another example of that, Larissa, is if we have something like this. Oops.
Yeah, because
So-
sometimes on the calculator you can't tell the difference between a triangle and a semicircle because of how the number you want to go by on your graph. Like if you go by smaller, it will then show it's a semicircle by the amount of the digits on your graph. But if you go by like a bigger number, then it looks like a triangle. That's my concern.
Because it's like that. So you gotta just kind of be careful with your upper bound and lower bound limits too, because that kind of helps you also. So if you zoom in using those ones, you can probably see the graph.
That's why I was asking for 18. I thought it was triangle, but is it a semicircle?
You're like 14.
I don't know, I have to look at it.
Triangle, okay.
So here we have a triangle right here, guys. See how we have a triangle right there? So we can calculate this area of the triangle, right there. Okay, so some more definitions, guys. The definition of a constant function, is the constant times the upper bound minus the lower bound. So when you take the integral of a constant for like the constant multiple rule and derivative, when you take the derivative, you, the constant is times, you throw that constant, what's the constant of a derivative? I mean, the derivative of a constant? Zero, right? So when you take the integral, when you take the integral of a constant, it's the constant times the upper bound minus the lower bound, okay? The upper bound minus the lower bound. So this, you have to use this definition when you're taking the integral of a constant. All right? So there's some more examples. I think I went through all the definitions. Yes, I did. The only thing I want to tell you guys about your homework is that you guys can take out number 26. Number 26 is just kind of more repetitive, and you don't have to do it, so you can mark it out just because it's with variables, and you don't need that, okay? You don't need that. So you can go ahead and get started on your homework. You have until 11:42, so